Today I'm going to summarize Newton's laws of motion. And Sir Isaac Newton was born 1642 and Galileo died in 1642. Some 2 decades later, 1666, a 24-year-old Sir Isaac Newton sitting under an apple tree and saw an apple fall from above. And he looked at the sky and he saw a moon. He wanted to solve apple fall, moon fall problem. To solve this apple fall, moon fall problem, he invented calculus. So from 1666 to 1670, he invented calculus. He published his work. He used the calculus to lay the foundation of physics, and he published the book 1687, and the book name is the Principia. Newton also used the calculus to write what we now call Newton's laws of motion. And today I'm going to go over Newton's 3 laws of motion, and I'm going to give you some examples. So first law of motion talks about inertia. What it talks about object at rest like to stay at rest, and object in motion like to stay in motion. For example, this object, this pink object sitting on the ring. If you talk about the free body diagram, what do you see? The force acting on this pink object is equal in magnitude, opposite in direction with the normal force, making the net force 0, acceleration is 0. So this is an example of Newton's first law, in which net force is 0. So on this pink object, net force is 0. Now you're going to talk about Newton's second law. And Newton's second law is by far the most famous law in the universe, F equal ma. This is a perfect example of Newton's second law. Why? Before you saw that object was sitting on the top of the ring, and then you saw when I remove the ring quickly, what happened with the pink object under free fall. So you saw the pink object was falling. It's speeding up. Why it is speeding up? It's speeding up because there is a velocity. There is a velocity at the direction of the acceleration. When the velocity vector and acceleration vector are the same direction, then the object is speeding up. What is the source of this velocity or acceleration? Net force. What is the source of this net force? Gravity. Gravity is the source of this net force. First, we're going to try to understand the kinematics of this falling body, and then we're going to try to understand the dynamics. The object is going to fall. All right, so object is falling. That means object is falling from height h. Object was falling from height h. So this is the dt graph. So there is an acceleration. So you're going to translate it to vt graph, and you're going to translate it to at graph. So if we take the absolute value of this one would look like this. If we take the absolute value of this one, and this one would look like this, then this becomes speed versus time graph. And if you take the absolute value of this one would look like this. So this is the kinematics of this falling body. Now we're going to try to understand why this is speeding up. As you see, this is speeding up. Why this object is speeding up? It's because the velocity is at the downward direction. Well, that doesn't make it speeding up. It's speeding up is because acceleration is still at the downward direction. When velocity and acceleration at the same direction, then the object is speeding up. What is the source of velocity and acceleration? Net force. What is the direction of the net force? Is still downward, also downward. Now what is the source of net force? Gravity. Gravity is the source of the net force. So once again, the object is speeding up because the velocity and acceleration at the same direction. That's why the object is speeding up. What is the source of velocity and acceleration? Well, net force is the source of velocity and acceleration. What is the net force? The net force is mass times acceleration. Okay, what is the mass? Mass is 1 kilogram. So this pink object is 1 kilogram. So what is the net force then? The net force is 1 kilogram, 9.8. So 9.8 Newton. So 9.8 Newton. So 9.8 Newton. All right. So what is the acceleration? Acceleration is 9.8 Newton divided by 1 kilogram. So acceleration is 9.8 meter per second square. Down. This is the reason the object is speeding up. And once again, what is the source of net force? Gravity. Gravity is the source of net force. Take you to Newton's third law. Newton's third law tells every action has equal and opposite reaction. It talks about actually normal force. We introduced normal force in the beginning, but Newton's third law is actually talks about normal force, which is reaction. What is the reaction force right now? Well, if you put one grape, then the magnitude of gravitational force and normal force would be equal in magnitude, opposite in direction. 2 grapes is still same, 3. But if you put lots of grapes, the normal force will give up. If you put a lot of grapes, then normal force will give up and the foil will break. This is another example of Newton's third law. Newton's third law talks about action and reaction forces. People often get confused. There is a misconception. If action is always equal to the reaction force, how would ever reindeer be moved the center forward who is sitting on the sled? Now let's see what happened. Center would be able to move forward is because reindeer accelerating forward is because there is a force coming from the reindeer, because reindeer exerting some force on the ground and ground exerting some force on the reindeer. That's one pair of force. Another pair of force is happening with the sled and the rope. Let's pay attention to the first pair of force. What is happening? Reindeer applying some force. Reindeer applying some force on the ground, and ground applies some force. Ground applies some force on reindeer, which is equal in magnitude, opposite in direction. If reindeer apply a little bit more force to the ground, then ground put a little bit more to the reindeer. Okay, how that help? Accelerating forward. Well, it's helpful because rope is putting some forces on the sled, which is equal in magnitude with this one. So rope applying some force on the sled. Okay, and the sled applying some force on the rope. This one is little bigger because this one is bigger. This one is bigger is because this one is bigger. And there is no third pair of force because is on the eyes, so it's frictionless. So reindeer moving forward. Now I'm going to talk about the elevator problem.